Hi, and welcome to Geeks for Geeks. I'm Siddharth Hazra, and today we would be discussing chocolate distribution problem. Talking about the feedback of this problem is well crafted, and if you are a beginner who is just learning sorting algorithms, then this problem is a perfect problem for you. Then let's move forward and understand the problem statement. This problem tells us that we have n packets of chocolate. Okay, we have n packets of chocolate. Now we are told that we need to distribute to it to m childrens. Okay, m childrens. Fair enough. So there are m childrens and there are n packets. And it is mentioned that the number of children would be less than equal to the number of packets. Okay. Now you need to distribute these all chocolates in such a manner that the difference between the maximum and the minimum is minimum. Fair enough. Now, let's talk about the very first brute force approach. So this tells us that we need to select m objects out of n. Okay. So this just means that we need to select subsets of n elements. So this just boils down to the problem that find all subset, and in those subset where the number of elements is m, we need to consider it. Okay, and then we should find the difference between the maximum and the minimum, and we can keep a variable which we would provide at the very end. So what you can do is, this would be a homework for you. You can just try to learn the importance of power set for this. Okay, power set for implementing this. Power set is very much important for interview perspective as well as for problem solving perspective, because this is a very important concept where we use the bit manipulation technique to find all subset. Okay, now this is the very first approach, and finding all subset of size n, okay, of size n would be very huge. Okay, and the number of elements are 10 to the power 5, so it won't be feasible. What would be the time complexity? The time complexity would be the time complexity of power set. What is the time complexity of power set? So as n elements would have 2 to the power n, then on each subset we need to count the number of elements as well as we need to consider the maximum and minimum. Let's say you just traversed once and then you find the maximum and minimum and then you do the difference. That would be 2 to the power n multiplied by n itself. Okay, this would be the time complexity, as 2 to the power 10 to the power 5 multiplied by 10 to the power 5 would be much greater than 10 to the power 8, and it is not the expected time complexity. So we would definitely get a time limit exceeded for this approach. Okay, now comes the point of optimization. Okay, well, the very first observation what I did was that, let's say I select, so we need to have the maximum and the minimum difference very less. Okay, so we want the global maximum and minimum to be less. So this is our end goal, global maximum minus global minimum. We need to lower it down. Okay, this is our end goal. So if this is our end goal, this just means that we need to point at every small element also, so that the globally it doesn't become big. We need to consider small cases. Okay, so if let's say we select a value x, okay, then the very next element should be just after x. Okay, it can't be more than x. So at this point I would just explain you the test cases too. So the very first test case is 8 number of elements are 8, and the number of people, that is the number of childrens, are 5, and the given elements are 3, 4, 1, 9, 56, 7, 9 and 12 itself. Okay, this is given itself. So we can see that if we are selecting one, let's say we are selecting this one, let's say we are selecting this one itself. Okay, we are selecting this one, then the very next element should be just after 1. What is the element just after 1? Then we should just select 3. Now if we have selected 3, then the next element should be just after 3, that is 4 itself. After that it should be 7 itself. Okay, so we can see that at each point to have the difference as minimum. So see, we want the global minimum. So small points should be consecutive in a sorted array. What I meant to say is that the very next element should follow them. So it is best that we select a sorted segment, so that every small element just after the small element, just let us sort this. This would make more sense. So we would first write 1, then we would write it as 3, then we would write it as 4, then we would write it as 7, then we would write it as 9, then again 9, then 12, then we have again 56, the value 56 itself. Now the consecutive segments, if you see that just after 1 we already have 3, just after 3 we already have 4, just after 4 we already have all the values. So now the answer can lie in 5 elements. So it can be either all this element, or it can be either all this element. And if you see this one, 3, 2, 9, see 3, smallest element is 3 and maximum element is 9. So this makes it a 6. Now let us see this. So if we select, let's say we have something like answer variable. Okay, and we initialize it with a very large value, let's say 200, because 200 is out of the reach of this. So if we select the very first segment of this, then the smallest one is 1 and the largest one is 9. So it is less than 200. So at this point we would update it with 8. Then if you observe, we can just select this, and the smallest is 3 and the largest is 9. 6 is less than 8, so we would update this to 6. Then if you observe, we have 4 to 12. The smallest one is 8. 12 minus 4 is 8, which is greater than 6, so we won't update it. Then we have 7 and 56, that is 49, so we won't update it. So what we can see is, now let's just sum up the observation according to the intuition. First, I saw that I need to select m elements. That just tells us that we need to consider all possible subset. So I would use power set. In the very next approach is, if I am select, let's say the value of m is just 2. So if we select 1, then the next value should be just after 1. Let's say we need to distribute chocolates among 2 people and the amount of difference should be less. So what we would do, let's say m is equals to just 2 itself. Let's say m here it is given as just 2. Then at this point, if you observe, if I take 1, then the next element should be definitely 3. If I take 3, the next element should be 3, 4. If I take 4 and 7, then the next element should be this and this. Okay. So this tells me that I need to do sorting. So if m is equals to 2, then it would be like this. After this, like this. Then it would be just like this. Then it would be 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 like this. So we can see it is just passing away. Okay. So now if m is greater, we would do the same thing. Okay. So we have 5 elements as this. The next one would be this. The next one would be this, and the next one would be this. This would be the nature of this. So now the idea is very simple. We would sort it. We would initialize the answer variable with a very large value. We would keep up a pointer. So this one would be, let's say this is, so 0, 1, 2, 3, 4, 5, 6, 7. So at this point you can see if I'm pointing here, the next pointer should point at here. Okay, so not here, this is just 4 elements. It should point here. So now if you observe this carefully, you would come to the conclusion that this point, if let's say it is I, then this point is nothing but I plus M. That is, let's say M was 5. That is M. But I plus M would be what? It would be pointing to this. But I want to point it to the less than 1. So I would just subtract 1. I want it to point here, but I plus M is pointing here. I would just point it to here. Now I would have 2 pointers. I and J would be equal to I plus M minus 1. And that would solve the purpose. Now I would keep moving forward until J is less than N. So the very first one would be like this, next one would be like this, and the next one would be like this, and the last one would be like this. So if you observe, J would first point to how much? It would point to this, then it would point to this, then it would point to this, then it would point to this. So we would keep moving forward. I would definitely be less than J. Suppose we have I plus 5. So I plus 5 would always be more than I. I plus 5 would always be more than I. So we would only handle the case for I. So this pointer is moving like this. So if this goes out of bound, then we don't need to care about this. This would always be less. So if this goes out of bound, we would stop at that condition. So now let us move to the implementation, and that would make the things more clear. Okay, so what I need to do is I need to initialize long answer is equals to very large value, as this is a long, so 1E18, and this would be very much good. How am I assuming that 1E18 would be sufficient? Because let's say the value of the elements can be 10 to the power 9. So at max the difference can be 10 to the power 9. This value can be 0, this value can be 10 to the power 9. So 10 to the power 18 is a very safe value, and taking 10 to the power 9 won't save any space. So 10 to the power 18 seems to be a very safe condition. So now I would sort this array. So this is sorting b dot begin comma a dot end, and then we would initialize for int I is equals to 0. This pointer would start from here, and jth pointer would be nothing but I plus M minus 1. Okay, and we would only consider the case where J is less than N. So we would just write a while loop while J is less than N itself. And then we would say answer is equals to minimum of answer, comma, A of, this is greater, this value would be greater because if we move this side in a sorted array, this would be greater. So maximum A of J minus A of I. Okay, we have it, and then at the end we need to return the answer, but we need to keep moving the pointers till the end. That is why you can have I plus plus and J plus plus. Let's compile and run. Yep, this is going good, and yes, we got an AC. A small optimization can be, instead of this, we can just use a post increment operator. What is this post increment operator? First, the value of J would be used, and then it would be incremented. So we can just use the value of post increment operator, and the code would look much more clean. Okay, so I would remove this and I would submit this again. Okay, so that's it for today. If you found something valuable, or if you were able to learn something out of it, make sure you comment and like the video so that the reach of this video could be increased and this work could be justified. That's it for today. Thank you and have a nice day.